So I mixed them up so we could keep remembering. All right, number 1, x is already by itself. It's already isolated. So all we have to do is take the root. If it is a cubic, what kind of root do we take? A cubed root. So we'll take the cubed root of this side and the cubed root of this side. Now 8 is actually a perfect cube. What number can we multiply times itself 3 times and get 8? 2. So this is simply x equals 2. Now, when we take cubed roots, we're just going to get one answer. Cubed roots are interesting. We can take a cubed root of a positive number, but we can also take a cubed root of a negative number. So if this problem were instead, if this problem had been to start with x cubed equals negative 8, we can still solve that. Because when we take the cubed root of both sides, the cubed root of negative 8 is negative 2. Okay? So if the problem had been that instead, we still just get one answer, but it would be negative. So odd roots, cubed roots, fifth roots, odd roots, you're going to end up with one answer. So if you're taking the root of a positive, your answer is positive. But if you're taking the cubed root of a negative, your answer is negative.
Why wouldn't it be 2?
That's if you do even roots. And we're going to do some of those, yeah. Okay, so the next one. The power is isolated. X to the third, there's nothing extra. So we take the root. Since this is a cubic, we take a cubed root. We do the cubed root of both sides. Okay, now it might be helpful to remind yourself of your perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and the last one we asked you to know earlier this year was 6 cubed is 216. So that would be as far as we would go. All right, so what is the cubed root of 27? 3. So this becomes x minus 3 equals 3. So now what do we do? Add 3. Now we get x equals 6. Okay, so to earn credit for your daily work today, you do need to be taking these notes. All right, number 3. This time we do have to isolate that x to a power. Something has to move first. What has to move? The 10 is plus 10. How do we undo that?
You subtract 10.
You subtract 10. Okay, so we get x cubed equals negative 27. Okay, so now we've isolated x to the power. So at this point, we take the root. So we're going to take the cubed root over here. And whatever we do to one side of the equation, we must do to the other. So we take the cubed root over there. So we get x equals. Now, we're taking a cubed root of a negative, so it's negative. And what is the cubed root of 27? 3.
I thought it would be 3i because it's a negative.
Okay, that would be true if we were taking an even root, like a square root.
Yeah.
But if we think about what is negative 3 times negative 3 times negative 3, that is negative 27. Okay. So that's why there's no I. We only get I when we're taking even roots. Really, square roots are the even roots we take. Okay, you tried number 4. You tried number 4, and if you're not sure what to do, you let me help you. Stop me.
Do we
Alright.
have calculators for like this unit or not?
You might need to.
I will check on that. All right, so the first thing we do is add the 11, and then we take the cubed root. And so the cubed root of 64 is 4. Okay, so number 5 has a fraction. And we're not generally fond of fractions, but they really aren't that hard. So whenever you see a fraction as a coefficient, just multiply by its reciprocal. So what's the reciprocal of 1/2, guys?
2.
2. Yeah. And there's going to be some on your homework in your regular class that are like this too, where you have to multiply by the reciprocal. All right, so 2 times 108 is 216. And now we have isolated our power, so we're going to take the root.
Simplify to 6, right?
Yeah, very good. X equals 6. All right, so number 6 has a lot of extra stuff, but I think you guys can do it. So I want you to try that one. And then I'll be happy to help you if you need me. And we'll go over it in a second. Okay, so we got,
I wasn't finished.
okay. Oh, wait just a minute more. Sorry about that.
No, it's 8. We're just gonna do the cubic part of it. See, yeah, she's doing it.
Okay, when you're ready to check your number 6, take a look and let me know if you have any questions. So we have to isolate the power, the x to a power. So the first thing that has to go in this one is the 5. So we subtract the 5. And then the second thing we have to move is the 2. So we divide by the 2. You have to use the inverse operation. So the opposite of adding is subtracting. The opposite of multiplying is dividing. So now we have x plus 5 cubed equals negative 8. So now we have to get rid of the power by taking the root. So it's a cubed root. The cubed root of negative 8 is negative 2. And then the last step is to solve for x. So we'll subtract that 5 from both sides and we get x equals negative 7. How'd you do?
Great.
Cool. Okay, so that's pretty much cubics. All right, now we're going to go back and review quadratics, but it's been a long time. So I don't expect you to exactly remember everything we did with quadratics way back in the day. So we're going to talk about how to solve this kind. All right. So instead of a cube, this is a square. So instead of a cubed root, what kind of root did we take? A square root. Now, even roots are different. When you take a square root, okay, you always get plus or minus. So when I take the square root of 9, I get positive and negative 3. Now that's different than cube root. Cube root, it's whatever the sign of the original number is. But with square root, you get a positive and a negative. So,
Sorry.
that's okay. It's okay. It's okay. All right. So, when we take the square root, we get plus or minus 3. So this kind of ends up being very similar to our absolute value, because at this point we have to set up two equations. This equal to the positive, and this equal to the negative.
So when it's only square root, you do plus or minus.
Correct. Cubed root you don't, square root you do.
I'm just like
Okay, so
writing
for
it down.
these we're going to end up with 2 answers. We can actually end up with 2 real answers, 1 real answer occasionally, and sometimes no real answers. If they're not real, what kind of answers are they? Imaginary. So, alright, so this one we would subtract the 7, and our first answer is x is negative 4. And then we get a second answer. When we subtract the 7 over here, we get that x can be negative 10. So with quadratics, usually we have 2 answers. Most of the time they're 2 real, and then sometimes they're 2 imaginary. Okay, so on this one, we got to get the squared part by itself. So what has to go first? The 43, that's right. And so we get 7x squared equals 77. Divide by 7, that's right. Now here we get x squared equals 11. So when we take the square root of this, we still get the positive and negative, but this time we end up with irrational. They're still real. Square roots of positives are still real, but they're irrational. And there's nothing I can do with that. The square root of 11 doesn't simplify. there's not a perfect square that divides into 11. 11 is prime, so the only things that divide into 11 are 1 and 11. So this doesn't simplify, and I can't take the square root of it. So that's just my answer. X equals positive or negative square root of 11, root 11. Okay, so sometimes they work out pretty, and sometimes they work out irrational. I don't think irrational is pretty. All right, this one we're going to add 8 first, and that gives us 120. So then we divide by 4, and we get x squared equals 30. So when I take the square root of both sides, 30 seems like an awful big number. Like a perfect square ought to divide into it, but it doesn't. I really want 4 to go in there, or 9 to go in there, or 16, or 20. Nothing divides in there. So even though 30 seems like a bigger number, that's it. That's all we can do. So we still get 2 answers. They're just weird. Just weird. All right, this one. This one turns out really pretty. We got a fraction though. So what did we say we do with a fraction? Multiply by reciprocal. So that's going to be the first thing we do, times 2. And we get x minus 4 equals 16. So now take the square root of both sides. And whenever you take a square root, you do get plus or minus. So what's the square root of 16? Does it simplify? Yeah, it simplifies to 4. So we get x minus 4 equals positive or negative 4. So now there's still some work. So if there's still some work, this is where we have to split it into the 2 equations. X minus 4 equals positive 4. X minus 4 equals negative 4. Alright, so we add 4 here, and we get x equals 8. We add 4 here, and we get x equals 0. So x equals 8 or 0. Those are our 2 answers. Alright, so we got another fraction. This fraction's different though. It's not 1/2. 1/2 is pretty easy. This one's 2/5. So if we did the reciprocal, it'd be 5/2. 5/2. Yeah. So you could either convert this to 2.5 times 16, or you could say 2 goes into 16 8 times, and 8 times 5 is 40. Yes, sir.
Could you just multiply by 5? Yeah, multiply by 5 at first and then divide by 2.
You sure can, yeah. That does the same thing. And if you guys like that better, you can do that. I'm going to pull this down. Just no, I'm not. Woo! Maybe went crazy. I'll just erase this. And I'm going to do it just like Colt just said. He said, can I multiply by 5 first? And then divide by 2. Sure. You sure can. It gives you the exact same thing. And if you guys like that better, do it that way. Instead of doing the entire reciprocal at once, you can multiply by the denominator and then divide by the numerator. But you can do reciprocal. You get the same thing either way. Alright, so now we have to take the square root. But 40 is not a perfect square. So we have to think about my perfect squares. Well, 4 is. And 4 divides into 40 how many times? 4 and 10. So when we simplify this, we can't take the square root of 40, but we can take the square root of 4. So this becomes plus or minus 2 roots of 10. 2 roots of 10. Because we can take the square root of 4. The square root of 4 is 2, but it leaves the 10 under the radical. Okay, so now when we move this number over, there's really not much we can do. We have to leave our answer like this, 4 plus or minus 2 roots of 10. Because remember, when we have radicals, you can only add things that are alike. And this one has a radical, and this one doesn't. So we can't really add them, we can just put them together. Okay, so I want to see what you can do with the rest of this worksheet. All that's left are squares and absolute value. And while you're working on that, I'm going to pass back the last quiz that you guys took for me. And it has your grade on it after I did looked at your corrections, okay? Yes. Again. So let's take a look at number 12. So number 12 is a square. So the first thing we have to do is isolate that power, get rid of our extra stuff. So we're going to add 5. And that gives us 4 times x plus 9 quantity squared equals 100. So then we divide by 4. And this one works out nicely because it gives us a perfect square. So that when we take the square root of both sides, we know the square root of 25 is positive or negative 5. And so when we subtract 9, we actually get 2 answers. Negative 9 plus 5 and negative 9 minus 5. Okay, so we get 2 real answers. Negative 9 plus 5 is negative 4, and negative 9 minus 5 is negative 14. So check and see. Did you get both answers?
Yes.
Cool. All right. I'm gonna snip these. Okay, so on this one we're gonna add 5, and then we just get x squared equals 25. So when I take the square root, I just get positive or negative 5. Nice, easy one. All right, absolute value. Now, with absolute value, once we isolate the absolute value, we set what's inside the absolute value bars equal to the positive and the negative. So we get x equals 20 or negative 14 when we add 3 to both sides. Okay, so check this one. This will be on our test next week. Absolute value was on your last quiz. It'll be on our test next week. All right, so we subtract 8 on this one. This one is not absolute value. This is a square. So we get x plus 3 squared equals 36. And then we take the square root of both sides. This one turns out pretty. So we get x 3 equals positive or negative 6. And we break it up. X plus 3 equals 6. X plus 3 equals negative 6. So when we subtract 3, we get x equals 3 or negative 9. Questions about number 15? Right, this one, when we add 11, we get 2 x squared equals 98. And then we divide by 2, and it works out so nicely. We get x squared equals 49. So we take the square root, and you get positive and negative 7. Okay, are you making corrections? All right, this one, x minus 8 equals 5. Excuse me, 2x minus 8. Or 2x minus 8 equals negative 5. In just a moment, I'm going to come check for completion and correction. So we're going to add 8. And we get 13. So when we divide by 2, we just have 13 halves. You could leave it 13 halves. You could also write it as 6.5. All right, here when we add 8, though, we get 3. So when we divide by 2, we get 3 halves, or 1.5. So if you switch those to decimals, it would look like this. Either of those are acceptable. All right, this one, we add the 9. We divide by the 5. Okay, now we have isolated the absolute value, so now we split it.
Can you do it? Okay, I didn't know.
Okay, so when you get to class today, or when you're working on today's homework from today's class, there's going to be cubics and there's going to be quadratics. So you got to pay attention. They're going to be mixed up. So sometimes you take the cubed root. How many answers do we get on a cubed root?
2. I mean 1.
1. Or there's going to be some where you have to take the square root. How many answers can we get on a square root?
2.
Okay, let's talk about why. Okay?
What was the math homework? Because we got like a review type of thing.
Today in class?
Today? Yeah.
Did you get a little half sheet also?
Is this little piece of
Okay.
sheet? Oh, we didn't get it.
Okay. You'll get that tomorrow then.
Hey, so is this? I'm not gonna be here.
Oh, I'll give it to you then.
Okay.
All right.
Miss Wildy, is this my grade for like regular math, the test?
It was your grade, but I added back points because you did corrections.
Okay.
Okay. So with a quadratic, like if we had this, y equals x squared, and we thought about this parabola, if we had it like that, it would touch the x-axis in one point. Okay? And if we think about that as an equation, that's one solution. The other thing a quadratic can do is it can be down here where it crosses in 2 points, which would give us 2 solutions. Now, the third thing this could do is it could be hanging up in here and never cross the x-axis, which would tell us that if we turn this into equation, there is no real solutions. So a quadratic could have 1 solution, 2 solutions, or no real. Now, we didn't work on these in class, but I want you to think about it because and we didn't work on them in support, but in regular class you will. You can have a problem like this, guys. X plus 1 squared equals negative 25. We can solve this algebraically, but our answers are not real. Because when we take the square root of a negative, what kind of number do we get? I. We get an imaginary. So we do get solutions, but they are not real solutions. They're imaginary. They're still answers. They're just not real. So when you get to your class, you're going to have some that are imaginary. And that's okay. And what that means is if we thought about the equation as a function, it just wouldn't cross the x-axis. Now, let's think about our cubic. A cubic crosses the x-axis how many times? 1. No matter how I move it around, it's going to cross once. So with a cubic, every time we're going to have 1 answer. So a quadratic could have 1, 2, or no real. It could just have imaginary. But a cubic will always have 1. Now, these are the cubics that we're giving you. It's possible to have a cubic that has more than 1, but those equations we won't give you. They look a little different.
Are you going to teach us all the different ones?
Nope. Nope. We're not doing those right now. All right. Yes, sir. When is our quiz in here? All right. So you have a test next Friday, the 20th, in your regular class, which means in here, let me ask you, would you rather test on Wednesday or Thursday?
Wednesday.
Okay, let's do it Wednesday, because then that gives us more chances to ask questions before our test in our regular class. So what we'll do is we will have our, yes, half of y'all have it before.
And Thursday is earlier Wednesday.
Oh, well then definitely Wednesday. So our support test will be Wednesday, 10/18. Okay? So that's when we'll have the test in here. Alright. If you guys have any other questions you can ask, we are done for the day.